Hey guys, welcome to Civil Engineers-Hardness. So today I'm going to calculate the moment of inertia of an unsymmetrical I-section. So we have all the unsymmetrical I-section here. So for the first thing, very important thing to note is all the dimension, that is 80 mm. The thickness of flange and web are 20 mm respectively, and the top flange is 80 mm and the bottom flange is 120 mm. So before getting into the moment of inertia calculation, we need to locate the centroid of the whole section. So we need to locate the centroid of the whole section. Let's assume that this is our centroid. Okay, let us assume the green section is the centroid of the whole section. So we need to calculate, and I'm just assuming one more section here. I'm just taking a reference section at the bottom flange here. So let me erase this. Okay, I'm taking it in the bottom flange here, reference section as 1 So you can consider the reference section at the top as well as bottom, and this is the distance between the reference section and the centroid. Let me call this as y bar. Okay, so the distance of the centroid from 1 So let's begin. So you can just see here, let me write here the distance of the centroid, from 1 is given by y bar. So y bar is equal to a1 y1. So we have three different areas here. We need to see that this is area A1 and this is area A2 after dividing the area here. So this complete thing is area A1, and we have area A2 as the red color which I am marking here, and the green color indicates the area A3. So this is the area A3. Okay, so this is area A1, A2, and this area is A3. Okay, and the respective centroids. Okay, the respective centroids is here. The centroid of the rectangular portion is here, and the centroid of the second area A2 is somewhere exactly at the center of the rectangle, and the centroid of the bottommost rectangle is also on the exactly at the center here. So for rectangle, you can just say that the centroid is at the center here. Okay, at the center here. So fine. So let's calculate the distances and the distances from the y-axis. So from the reference section, it is calculated as follows. Okay, so the distance from this section is, so the centroid is somewhere here. So this distance is y1. The distance is y1. And from here, from the center of this to the reference section, complete reference section 1 the distance is again y2. And lastly, we have the distance from the centroid to the reference section, this as our y3. Okay, so we have to calculate. So we understood what is y1. So let's calculate a1 y1 plus a2 y2 plus plus a3 y3 divided by total area A. Okay, so let's calculate the values here. So what is the area 1 here? This is our area 1. So area 1 has a rectangular part, that is 80 into 20. So let's calculate area A1 is 80 into 20, that is 1600 mm. Okay, now area A2. So for area A2, what we have here is the area of this section. So its length is 140 and thickness is 20. So 140 into 20, which is 14 2 is 28, 2800 mm. Okay, so now we have the area A3. What is the area A3 here? The bottom flange 120 into 20, thickness 20. So 120 mm into thickness 20, that is 12 to the 24, 2400 mm. So this is the total 3 areas. So if I add all those, the total area A is A1 plus A2 plus A3, so which is 1600 plus 2800 plus 2400. So the total area works out to be 6800 mm square. Okay, this is the total area. So now we have got this area A1, A2, A3 and A, and now it's time for getting the distances Y1, Y2 and Y3. Okay, so we'll get that distances now. So what is the distance Y1 here? So the Y1 distance is written as, just be careful here, so 140 plus half of this. So here you have the half of this, you should take the half of this value, so that is simply 10 mm plus 10 and entirely this thickness, because this is the 140 is only up to this portion here, so plus 20 of the bottom flare. So the total will be 140, 160, 170. So Y1 is 170. So what is Y1? So the Y1 is 170 mm. So now it's time to calculate Y2. So what is Y2? So where is Y2 here? So this is Y2 here. So fine. So let's calculate the distance for Y2. So for Y2, what you have to do is, actually I'll just take the Y2 here so that it will be convenient for me to show you guys. So this is Y2. So for Y2 you have to make this portion, this is half of this, so this is 70 here and this is also 70, because it is the rectangle, so half of that is 140 divided by 2, that is 70 mm 70. So Y2 is, first you have to calculate 70, you got this 70, you traveled up to here, and then again you need to travel up to this end, this section 11. So that is how much is the thickness, plus 20, so it is totally 90 mm. So Y2 is totally 90 mm. So let's write here Y2 is 90 mm, and let's calculate Y3. I think Y3 will be the most easiest thing, because the Y3 is very close to the section 11, the reference section 11. So it will be directly, it will be thickness, half of the thickness, that is 20 divided by 2, that is 10 mm. Okay, so the thickness Y3 will be 10 mm. So let me write it in red only. Okay, it will be 10 mm. Fine. So now what we'll do is, we have got all things. Now let's calculate the distance of the centroid, means the centroidal distance of an unsymmetrical I-section. So Y bar, so let's put the values here. So Y bar, okay, sorry, I think this is getting, let me select the shape here, I don't want this to select. Okay, fine, now we got this. So Y bar is A1 Y1 plus A2 Y2 plus A3 Y3 divided by total A. So in that way, so 1600 into Y1, the distance Y1 is 170 plus A2 is what? It is 2800 into Y2 is 90 mm plus A3 is 2400 into the respective Y3 distance is 10 divided by entire area. Okay, area of cross section that we have already calculated, that is 6800. So the Y bar, the centroidal distance Y bar is, I have calculated this, so let me calculate. So I have already calculated the distance, that is 80.588 mm, 80.588 mm. So this is the centroidal distance. The meaning of this 80.588 mm is that, okay, so what is the meaning of this distance? Okay, so you must ensure, or you must know that the I section what we have got, the unsymmetrical I section whatever we have got here, the centroid of that I section is 80.5, sorry, I've just written 50 here, sorry guys. So this is 80.588 mm from the bottom edge of the I section. This is the meaning, which means, let me take here. So this was my assumed centroidal axis. This was my assumed centroidal axis. So that value here, it is, sorry, this is very thick here. Okay, so that value here, it works out to be 80.588 mm, 588 mm. Okay, so this is 80.588 mm. So I hope you got how to calculate the centroid of the this this is just a centroidal distance. Now we need to calculate the IXX, that is moment of inertia in XX direction and moment of inertia in YY direction, which means this is your, always just remember, horizontal is your XX direction while the vertical is YY direction. So very important thing to note here, or just to understand the concept behind this, is that the section is symmetrical about the y-axis. What I mean to say is that the section is symmetrical here, the entire section, this section, let me draw a line here. Okay, so the section is entirely symmetrical about this YY axis. So this is the YY axis here. So let me take another color here. So this is the YY axis. The section is symmetrical about the YY axis. But when it comes to the XX axis, when it is symmetrical here. Okay. When it comes to the XX axis, it is not symmetrical because there is 80 mm in the top flange and bottom it is 120 mm. So you have an unsymmetricity here. So we have to calculate IXX separately and IYY separately. Okay, so for calculating moment of inertia, let's begin. Okay, so let me draw the diagram once again, and now we need to calculate the IXX and IYY here. So let's calculate the IXX and IYY here. Okay, so for that we have the formula. So for calculating the IXX, we have the formula, that is, it is for rectangle, it is BD cube by 12 plus BD cube by 12 into AH square. Okay, A is the area of that respective section and H square. So this is the formula. Okay, so this is every step very clearly. Okay, so for that you need to calculate for H. What is this H? Everyone has a doubt here, that is H. What is the H distance H here? So the distance H is the distance between the respective sections. So we have 3 sections here. First 1, 2 and 3 geometrical rectangle sections of different areas that we have already seen. So we expect 3 H, that is H1, H2 and H3 distances from the centroidal axis. Very careful, from the centroidal axis, that is the distance between the centroid of area A1 and the centroidal axis is your H1. And next, the distance between the centroidal axis of area 2 and the centroidal axis is the distance H2. And lastly, you have the distance H3 as the distance between the centroidal axis and the third area, center of the third area. Okay, so the center of the third area, this is the distance, that is H3. So for that, what I will have to do, let me show you. the calculations of h1, h2 and h3, and then I will begin. So just see, I have not marked the distances y1, y2 and y3. That is not needed now. How you got this value 99.412? I just got that value from dividing, that is the total length of the I-beam, the total height is the complete from one end to the other end, the total height is 180 mm. So for that, what you need to do is that 180, completely 180 minus 80.588. okay, 80.588. so 180 minus 80.588, if you do, you get it as 99.412 mm. okay, fine. So now I will tell you how to calculate the distance h1 here. So for calculating the distance h1, firstly you have to see that the distance from here, complete distance is 99.412, but you need the distance from the half of the flange here. You need the distance from the half of the flange. So minus 20 by 2, minus 20 by 2. Okay, so for that value is, it is 89.412 mm. So as simple as that. Okay, so you got the distance h1 is 89.412, and next we need the distance h2 here. So h2 is very simple actually. So you can just see the distance is h2 here, but to get that distance it's quite tricky. So what you need to do is, first complete distance you know here, that is 99.412 is a complete distance here. So let me rub this, otherwise it will be a doubt, it will be a obstruction here. So now 99.412, and you need to get only this distance. You need only this distance here, h2. So minus 20. So minus 20 this distance, and again you know that this distance is 70. Since it is a symmetric here, that is 70, because the section here, the flange width, sorry, the web, this is web, sorry, the web width is 140. The total web width is 140. So 140 by 2, 70 minus 70 if you do, because total 20 minus 70 if you do, then you will come up to here. So this is what you require. Okay, so let's see, 99 point this one minus 20 and minus 90. So this you will get as 99.412 minus 90. So this is 9.412. okay, 9.412 mm. Okay, so now we need to get the distance h3 here. So h3 is the distance, like how you'll get this distance. So you have 80.588, this entire thing now 80.588 minus, you have to see that the distance is from the centroid of the area A3, so minus 10. So just minus 10, that is 20 by 2, actually minus 20 by 2. That directly I have written, actually I'll write in detail. So this is 70.588. h3 is 70.588 mm. So now we are going to actually calculate the IXX. So for calculating the IXX, you should be very much careful. It's my own trick that I follow to calculate the IXX. Just remember, the x direction is the horizontal direction, as we all know. What you need to do is that whenever you select any shape, first I am selecting the area A1, so you have to consider its XX part as B. You have to consider this XX part as B, which means, let me draw a rough sketch here, very rough sketch, please don't mind guys, please don't mind. So whenever if you're taking the area A1, this is area A1, area A2 and area A3. So if you're considering the area A1, then you have to consider that this section has an XX axis in this way. Means XS, the XX, this becomes your breadth, this becomes your breadth, and the depth will become this part. Okay, and for this area and for the area A2, this portion becomes the breadth and this portion becomes the depth, because always you have to consider, I told you, the breadth should always be on the XX axis, and now the XX axis of this, the XX axis of this component is here itself, means breadth, depth, and lastly this itself is same. Again you have to consider your XX axis here, that is, this is the breadth and this is depth. Okay, that is the major thing many people do mistake. So let's calculate the Ixx now. So let me calculate Ixx of first one. So B, first part above is the first area, this one 80 into 20. So B is 80, D is 20. BD cube. So B into D cube. So 12, BD cube by 12 plus area of that section is 1600 into, very important thing, AH square into AH square, as the formula says here, AH square, that is BD cube by 12 in plus AH square. So now you have the H square, H1, you have to see the H1 square here. So you have to see the H1 square. You have to see the H1, that is 89.412, that is 89.412 the whole square, plus same thing, the same thing will get repeated for the area A2 here. So what I'm going to do next, this is the breadth. Okay, now next part, this is the breadth. So 20 is this area, 20 and 120. So the thickness here is 20 and the depth is 140. Okay, here the breadth was 80 and depth is 20. So 20 into 140, yes, BD cube by 12 plus area is 2800 into 9.412 the whole square. Okay, 9.412 the whole square. So let me rub this here. It is a little bit, I'll write in a small 1412 the whole square. Okay, this is the H2 and this is the value of H1 square. And next, plus last thing, last part is area A3. For area A3, the breadth is 120 and depth is again 20. So BD cube, BD cube, what is D cube? D is 20 cube. Okay, BD cube by 12. Okay, so so guys, one mistake, small mistake I have made is B. So the breadth here is 80 and here it is 20. Sorry guys, this is 20, the depth is 20 for first one. Sorry guys, I just made a small mistake here. This is 20, BD cube by 12, 80 into 20 cube by 12 plus 1600 into, everything is same, BD cube by 12 plus 2400 is the area into 70.588 square, that is H3, that is your H3. Okay, height H3. Now we need to calculate the value of Ixx. So guys, I have calculated, so I have got the value as 29.7043 into 10 to the power 6 mm raised to 4. Okay, mm raised to 4. This is the Ixx value Now I'll get Iyy value. So for calculating Iyy value, my dear friends, we need not be very much, we need not have the h1 value. So I'll just explain you. So this is the shape, actual shape. Just sorry for not good. I'm not a very good in figures. So okay, so now we know this is 80, this is 120, and all the thicknesses are 20, 20, 20, 20 and 20. This is 20. Okay, so fine. So sorry, so this is also 20. Okay, so but we know that the section, I previously discussed that the section is symmetrical about the y axis. The section is symmetrical about the y axis. Okay, it is symmetrical about this y axis, which means that when it is symmetrical about y axis, then we don't have any h1 values. We don't get the h values, since the center, all the center of the rectangles, all the centers of the rectangles a1, a2 and a3, all they lie on the y axis. All the three centroids lie on the y axis. The h1 distance is 0, and h2 is 0, and h3 is also 0. So for only the Iyy, for calculating the Iyy, the only thing required will be BD cube by 12 for the three sections. Okay, BD cube by 12 for section 1 plus BD cube by 12 for section 2 plus BD cube by 12 for section 3. Okay, so for that, let's see what will be the B and D for YY. So one hint I'm just giving you all guys is, it's a trick, it's my own trick, that you have to consider. So whenever you are selecting this section here, just let me take the section of this one. First section, it is 80 and 20. Now here you need to consider your y axis in this way. You need to consider y axis in this way. So when you consider a y axis in this way, you have to select the breadth. Means you have to consider this, the thickness of the web becomes your breadth, and the entire thing of the length of the flange becomes the depth. Means the B will change to D and D will become your B. Okay, so for this similar figure also, for the second figure here, again you have to consider the y axis here itself. Since y is vertical, and the breadth becomes, this becomes your breadth. Now this becomes your breadth, and the depth becomes this one. And similar thing for the section 3. Here what it means is Iyy. So B, the breadth here is 20, D cube, D is 80 cube by 12, and the rest of the things I told you, as I told you, it is h1, h2, h3, so that is ah square. The term becomes 0. Okay, plus now BD cube by 12 for second figure. What is the breadth? Breadth is 140, depth is again 20 cube by 12. For last figure it is B. So this is the last figure here. So this is 120 and 20. Again my y axis is here, somewhere here. So y axis. So the depth is your breadth now, which means this is your breadth and this is my depth. So B D cube. So 120 cube BD cube by 12. So this will give me around 3.8267 into 10 to the power 6 mm raised to 4. So Iyy is 3.8267 0.8267 into 6 into 10 to the power 6 raised to mm raised to 4. So the final moment of inertia, that is I, or you can even say the polar moment of inertia, the polar moment of inertia. The polar moment of inertia I is calculated as Ixx plus Iyy, which is, what is the Ixx value? That is, we got it as 29.7043, 29.7043 into 10 to the power 6 plus 3.8267 into 10 to the power 6. So finally we get this as, let me calculate here. So 33.531 into 10 to the power 6 mm raised to 4. So in this way we calculate the moment of inertia of an unsymmetrical I-section. Okay, so I hope you understood how we calculate the moment of inertia of an unsymmetrical I-section. So please don't forget to subscribe my channel. Okay, so let me meet you in my next video with some other concept. Till then, take care.